Hi, hello students. Welcome back to the YouTube channel for IGCSE-Computer Science Chapter 2. We are learning data transmission, and in the previous videos we have mentioned about the types of transmission methods, the types of directions, the how the transmission takes place, and the synchronization methods which is used in the transmission. We have learned in the previous videos. So if you are not clear in that, please go through the previous videos. So in this video we will start error detection and correction. So before getting into this topic, we all know if there is any transmission takes place, there may be possible of any errors, right? Okay, so in case the error occurs, what are the methods that can be solved? Error detection and correction it is. These methods are used to detect the errors, and it is also going to correct the errors. So in this video session we will learn the purpose of error detection, why the error detections and correction methods are used, and what are the techniques which has been used in the error detections, working methodology of error detections and correction, and some exam pattern questions also we'll discuss about it. Yeah, okay, so we'll get into this. So any transmission, I repeat, any transmission takes place, there may be possible of errors, and the transmission is between always the sender and receiver, right? So the sender is sending a data, and the receiver is supposed to receive the same data. There shouldn't be any error, because the transmission will take place in some cases of wired or wireless transmissions. So there may be possible of crashes or the data lost. So many possibilities are there. In these cases, what are the methods are going to take over this issue? So error is an issue, isn't it? We are sending an email. Our receiver is not receiving the complete content of the email. So there may be errors in the transmission, right? So that is what the errors in transmission. So here in this chapter, we will discuss what are the types of error detections and correction methods are used. The first one is parity check, right? So this is very common method. These are the 5 methods: parity check, ARQ, checksum, echo check, check digit. So these are the 5 methods commonly used to detect errors, and automatically it will correct it sometimes. Yeah. So what is happening in this error detection correction methods? The data will start transmitting from sender to receiver. If the receiver is not receiving the correct data, some kind of signal sends back to the sender. The sender will transmit the data again. It will retransmit the data. First, we will get into the parity check. In parity check, we all know that data is in binary forms, isn't it? That is a binary form of data. So when some binary form of data is being transmitted from sender to receiver, there is an additional bit will be added with that. Okay, parity check uses an extra bit. Look at this figure. How many bits in the data actually? 3, 6, 7 bits are there in the data. When the data get transmit, one extra bit is added with that, right? In receiving data, how many bits are there? There will be 8 bits. The original data has 7 bits, and extra bit is added with that. That is called parity bit. Okay, I repeat, with the raw data, the original data, an extra bit is added with that. That is called parity bit. This bit ensures whether the data transmitted correctly, right? So two types of parity checks has been used here: odd parity and even parity. It doesn't mean anything. That means the number of ones we are thinking about. If it is odd parity check, odd number of ones in the data while it is received. If it is even parity check, even number of ones should be in the data while it is receiving. Okay, so look at this example. How many ones are in this data? It uses, this is about odd parity, right? The making the sense of data with odd number of ones. Okay, how many ones are there? 1, 2, 3, 4, 5. So this data is correct, right? And here how many number of ones are there? there are four number 1, 2, 3, 4. Four number of ones is not odd, so this is a wrong data while it is receiving. So once again I am saying what is parity check. With the actual data, an additional bit will be added, whether it is right side or left side is not a problem. An extra bit will be added with the actual data. That bit is known as parity bit. This ensures the data transmitted correctly, and it uses two types of parity check: odd parity check, even parity check. Even parity makes even number of ones, odd parity makes odd number of ones. Okay, so some examples also given. Tell me from these two which one is correct, right? Okay, so how many number of ones and zeros? 2, 3, 4, 5, 6. So according to even parity check, 6 number of ones, that is correct. And here 1, 2, 3, 5. I am just counting the number of ones. Keep it in your mind. I am not counting the number of zeros, number of ones I am counting. 1, 2, 3, 4, 5. So this data is wrong since it is not even number of ones. Got it? Okay, we'll get into some examples. Before that, one drawback is there while the sender or receiver uses parity check. If the sender or receiver using a parity check as a error detection method, there is a drawback. It doesn't work with transposition error. What is transposition error? So I am writing some number of bits here. Say for example, a sender wants to transmit 1, 1, 0, 0, 1, 0. Since it is 6 bits are there, okay, keep it in your mind. This is the data which the sender wants to send. So, right, this is the actual data, and this system is going to use even number of ones. Okay, even number of ones. So, what is the extra bit is going to add? See, since I am not writing it neatly, I'll write one more time. I'll try to write it neatly. Okay, 1, 1, 0, 1, 0, 0. Okay, 6 bits are there in this. This is the actual data the sender wants to send, and the system has decided it is going to use even parity check. So with the actual data, one extra bit will be added. Okay, some bit, either it is 0 or 1 is going to be. Now the system uses even parity check. Which bit is going to fill this, whether it is 0 or 1. Already how many number of ones are there? 1, 2, 3. So it is not even. If you make 1 here, it is even now. Got it? This is even parity check. Okay, now this data all together will get transmitted, right? Okay, the data got transmitted. Now the receiver is receiving like this: 1, 0, 1, 1, 0, 0, 1. Okay, so now my question is, the sender transmitted this data with this parity bit. So how many number of ones? It is even, right? It uses even. Okay, right? Once it got transmitted, the receiver is receiving the data in this way. Now tell me, is this a correct data or wrong data? Is this correct data or wrong data? My question is, it is actually wrong data, right? Here it is 110100. Here it is 101100. So obviously it is wrong data. But according to the even parity check, is this correct? Yes, obviously it is correct, because 1, 2, 3, 4 number of ones are there. So it uses even parity check, right? So according to the even parity check, it works correctly, but the data which is received is wrong. So this is known as transposition error. The bits are, instead of 1, 0, it has been replaced as 0, 1. The bits are transposition. The bits are exchanged. That is called transposition. The position of the bits are exchanged. Okay. So this is very important point. The parity check is not going to work with transposition error. So hope it's clear with odd parity check and even parity check, right? The number of ones is odd, odd parity check. The number of ones is even, even parity check. Okay. So look at this example, right? So this system uses even parity. Which of these bytes have been transmitted correctly? Should listen the question. Which are the bytes transmitted correctly? The system uses even parity check. So whichever data transmitted correctly, we have to say. So okay, is this transmitted correctly? How many number of ones are there? 1, 2, 3. Is this transmitted correctly? No, it is wrong. Right? Okay, next one. Is this transmitted correctly? Yes, 1, 2, 3, 4. So this transmitted correctly. Next, this one. Is this transmitted correctly? How many number of ones are there? 1, 2, 3, 4, 5, 6. So this is also transmitted correctly. Right? And this one? 1, 2, 3, 4, 5. Is that transmitted correctly? No, it is wrong. Then the last one, 1, 2, 3, 4, 5, 6. So yes, it is transmitted correctly because it uses even parity check. We are counting even number of ones, right? Okay, let's see whether our answers are correct or wrong. Yes, it's correct, right? So first one is incorrect transmission. Second one is correct, correct, incorrect, correct. We did that. You understand? Yes. Okay, the another example. This has a table which contains the binary values of alphabets, and the word flowchart has been converted in a binary form. Okay, we are going to make which byte or column is not transmitted correctly. Okay, I repeat, this system uses even parity check. Okay, there is a transmission error. If one bit is not transmitted, that there might be transmission error, right? Yeah, that is what we are going to find in this table. Okay, so first we will start vertically and horizontally we'll do. Okay, vertically we will start the number of ones in column 1. 1, 2, 3, 4, 5, 6, 7, 8, sorry, 5, 6, 7, 8. So this transmitted correctly. How many number of ones are there? Yes, 8 number of ones are there. It is given, right? Okay, this one. There is 0 number of ones. Is it odd or even? Yeah, 0 is even. Keep it in your mind. Okay. Column 3. How many number of ones are there? 2, 4, 6, 8, 10. So this is also even. Column 4. 1, 2, 3, 4. It is also even, right? Column 5. 1, 2, 3, 4. It is also even. I think you are following what I am doing, right? If you want to find which byte or which column is not transmitted correctly, we have to check the row wise and column wise. Then only we can find out. Okay, follow me what I am doing. Then column 6. 1, 2, 3, 4, 5, 6, 7. So column 6 has been transmitted incorrectly. The question is not over. Keep it in your mind. The question is not over. Okay, continue with that. 1, 2, 3, 4, 5, 6. This is also transmitted correctly. 1, 2, 3, 4. This one also transmitted correctly. So column 6 is got incorrect transmission, but we don't know which bit has been corrupted, isn't it? Do you know that whether it is first bit or second bit or third bit? We don't know which bit is corrupted. For that we have to trace row wise. Okay, so first for byte 1, 1, 2, 3, 4. 4 is given, so that also transmitted correctly. Byte 2, 1, 2, 3, 4 transmitted correctly. Byte 3, 1, 2, 3, 4, 5, 6 transmitted correctly. Byte 4 1, 2, 3, 4, 5, 6 transmitted correctly. Byte 5 1, 2, 3, 4 transmitted correctly. Byte 6 1, 2 transmitted correctly. 2 is even, right? Yes. Byte 7, right? 1, 2, 3. So byte 7 got incorrect transmission. 3 is even. It's not even, right? It is odd. Then let's check byte 8. 1, 2, 3, 4 transmitted correctly. Byte 9 1, 2, 3, 4 transmitted correctly. And parity byte 1, 2, 3, 4, 5, 6. That is also correct. So now which byte has been transmitted incorrectly and which column has been transmitted incorrectly we have found. So exactly if you want to find out which bit is corrupted, you can connect with the junction of that. This is a bit which is having incorrect transmission. So if you change this as 0, everything will be solved. Right? Now I have changed that to 0, 1, 2, 3, 4, 5, 5, 6. It's over. So I am repeating. I'm taking eraser and erasing it. Okay. Look at this. When I change this to 0, 1 has been removed. It is 0 if the bit is corrected. 1, 2, 3, 4, 5, 6. It is solved. Column 6 is solved. And also byte 7. 1, 2. That is also solved. Got it? So this is the bit which is corrupted. And which byte is corrupted? Byte 7. Which column is corrupted? Column 6. And which is the bit? This is the bit. Okay. Clear? Hope it's very well clear about it. Okay, we'll jump into the next example. If a system uses even parity, give the parity bit for each of the following bytes. Tell me the answer. Even parity has been used. 1, 2, 3, 4. Already 4 ones are there. So what it is going to fill? Yes, it is 0. If I make 1 here, that is going to be odd, right? So it can't be an odd. Okay, here in data, how many number of ones are there? Only 1. That is odd, but system needs even parity. What is going to fill here? It is 1. Okay, hope it's very well clear about it. Then this example, still it is using even parity byte, received byte transmitted correctly, byte transmitted incorrectly. How many number of ones are there? It is 3. Is that transmitted correctly or incorrectly? Yes, it is incorrect transmission because odd number of ones are there. System uses even parity check. Next one, 1, 2, 3, 4, 5. Transmitted correctly or incorrectly? 5 is odd. System uses even, so transmitted incorrectly. The last one, 4 number of ones transmitted correctly. I hope it's very well clear about parity check. I repeat, parity check is a method used to correct the errors. It uses an extra bit with the actual data to ensure whether the transmission is correct. Okay, the extra bit is known as parity bit. Keep it in your mind. Okay, so this is another example you have to do as your workbook. In your workbook, complete that, and still it uses even parity. Okay, it uses even parity. Okay. You can do that. I'm not going to explain. Then the next error detection method is ARQ. Stands for automatic repeat query or else automatic repeat request, you can say. Okay, so get into this. What is happening in this? The sender started transmitting a data. Always the sender will start transmitting the data and the receiver receive. In this type of transmission, ARQ, this uses timer and acknowledgement as a tool to complete the transmission. Okay, the sender is started transmitting a data, then the timing signal will start. Within the particular timer, the receiver have to send a receipt that is known as acknowledgement. Okay, say for example a sender is sending data that suddenly it got corrupted somewhere. The receiver did not receive. Within the particular timeout, the receiver is not going to send any acknowledgement. So the sender identifies, okay, the data is not transmitted correctly. Okay, then it will retransmit the data once the time is up. That is what it will happen in ARQ. I repeat, the sender started transmitting the data. If the data is received by the receiver immediately will send an acknowledgement to the sender. So in case of data get corrupted, the receiver couldn't send any acknowledgement to the sender. So the sender identifies, okay, the transmission is incomplete. So send the same data again to the receiver. Now the receiver is receiving the data and the receiver is sending back an acknowledgement to the sender. Now the transmission is complete. Okay, so look at this. These error detection method use acknowledgement and timeouts. The sender will start transmitting. Once the receiver received the data, the receiver needs to send an acknowledgement, which is a very important point in this ARQ. The receiver will send an acknowledgement to the sender. This should happen before the timeout occurs. That is what ARQ. Okay, hope it's very well clear. The next, third one is checksum. Here, whatever we are sending, the sender is sending as a data. Using the data, the system will generate a value. Okay, and program will execute with the data whatever you are trying to send. The sender is trying to send the data. The system will automatically execute a program to generate a value. Okay, any value which is calculated using ASCII value or a binary value for the data. The data is there. In this example, Fox is the data. This data will be taken in a program. Output of that program is a value. This value is known as checksum. Okay, this value will be added with the data. Clear? This data and the value calculated using the program will be sent to the receiver. The receiver will execute the same program which is used to create the value, and if the value is equal, the data transmission is completed. Otherwise, the sender will transmit again. Okay, so look at this. Data will be separated and sent in blocks. Each blocks will be added with a value which is calculated by using the binary values of block of data, maybe binary value or ASCII value. This checksum will be generated using different types of algorithm. That is a program. Okay, so look at this example. Sender wants to send a file. Okay, sender wants to send a file. When the transmission started, the file has been taken to a cryptography program. I repeat, the file or a data. Imagine this is a data. Okay, I'm just giving a word file, but it is a data. Anything it is. That has been taken into a program, cryptography program. The output of this program is a value that is called checksum. Okay, that is called checksum. This checksum value will be added with the data. Look at this. File is attached with the value checksum. Okay. Now, when the receiver received the value and the data, the checksum and the data, the receiver execute the same cryptography program and send this data as an input and getting the checksum value, right? That value and this value, if it is equal, the transmission is completed. Otherwise, the sender receiver will send some signals to retransmit the data. The sender will transmit the data. Again, the same process will take place. Okay. So I repeat, the data is sending it to the program, and the output of that program is a value which is known as checksum. That checksum value will be added with the block of data. Once the receiver received, the receiver also executes the same program for the given data, the data which is received, if the output value is equal to the checksum which is received, the transmission completed, otherwise it is incomplete. Okay, the sender will retransmit the data. Hope it's clear. Yeah, okay. The next one is echo check. So from the word itself you can say that. So echo check means bouncing back the data. Okay, look at this. Copy of original data will be sent by the sender. Okay, say for example we have a sample hello. Hello is there in the sender, and copy of this hello will be sent to the receiver to receive the data. Once the receiver received any data, that data will be sent back to the sender. That is, and original data will be kept it in the receiver. The copy of that will be sent to the sender. Now what the sender will compare, the sent data and the received data. If it is equal, no action to be taken. Otherwise, the sender will retransmit the data again. Okay, that is all. The copy of original data will be sent by the sender. Once the receiver received the data, when the copy of the same data will be sent back to the sender. Sender will now compare the original data with the received data. If it matches, sender is not going to do anything. If it is not matches, the sender will retransmit the same data again. That is what the echo check means, right? So thank you for watching the video. Check digit and the exam pattern questions will be given in the next video with some examples also. So check digit, I will just give a hint about check digit. It has been used in barcode. You can take a look at the barcode. Barcode uses some 13 or 16 digits of sequence of numbers. Using those numbers, a program will be executed like the same way as checksum. In checksum, it will be output a large value, but in check digit, the output will be a single digit. Okay, some of the example I will explain it in the next video. You can watch, and please subscribe the channel for the further videos. Thank you for watching. We'll continue in the next video. Thank you.